Now let's do an example. In this example, we are given a 3-address code which is also in single assignment form. That means each variable appears only once on the left hand side. And we have to apply all those optimizations. We might have to apply those optimizations multiple times, and our goal is to optimize this code as much as possible. In order to understand clearly, I have written this code again here so that I will perform all the optimization on this side, keeping the original example as it is. Let's first start with the constant folding. We have to see equations where the right hand side has only the constants. This equation and this equation has only the constant on the right hand side. However, here we can't do any optimization of constant folding because this is already in simplified form. But this we can make it more simpler by solving it at compile time. So this will become 13 Let's mark each optimization so that we can remember what optimization we have performed on what line of the code. So here we have performed constant folding. Next, we try to perform arithmetic simplification on our 3-address codes. We can perform arithmetic simplification here and here. So this will simplify to A equals to A plus B. We have performed here arithmetic simplification, so we marked it. Similarly, this will simplify to R left shift 5 times. We mark it with 2. Now let's perform copy propagation. Here we have C is equals to A. That means wherever we have C, we can replace it by A. We replace this C by A. It will become A plus B. We mark it with 3, which is copy propagation. Similarly, we have C here. We replace it by A. It will become A plus X. We mark it with 3. We don't have any more C anywhere. So we are done with our copy propagation. Next we do constant propagation. We have a constant here. That means anywhere where we have X on the right hand side, we replace it by 13. So we have X here. We replace this X by 13. And here I mark it with 4 also. Similarly, we have X here. I replace this X with 13. Also, I have here 19. S is equals to 19. So that means anywhere where we have S, we can replace it by 19. I replace this S by 19. And now I'm done with my constant propagation. However, because it is an iterative process, so we can perform here constant folding, make it more simplified. So I solve this at compile time. 19 plus 13 is 33. So this will be replaced by 33. And I mark here my constant folding. So I have performed on this line of code constant propagation and constant folding. Next, I look for the common subexpression elimination. That means if I have A plus B here and also A plus B here, then this A plus B can be replaced by simply A. So I replace this A plus B by A. And I mark that I have performed common subexpression on this line of code. And I think that's it. and we can't perform any more optimizations here. So I hope that this example would have helped you in understanding these optimizations much better. See you next time. Bye.